A simple explanation: expanding under the pressure of expanding space that is seeping up in between the galaxy, like water seeps up between two laying leaves in a lake from the bottom, separating the leaves apart. But for the universe, there exists a balloon-type bubble at its center of mass, slowly and at a constant, the Hubble constant, growing from this concentrated round mass that was created at the same time by the Big Bang at the time of creation. This bubble has put a time limit on our universe, so a few physicists believe. Physicists have foretold a 0-point time start for creation in all the physics books across the table, and that this expansion rate seems to be evolving, multiplying, and erecting the space liquid. In the analogy, Rodney Kavetsky has deciphered the strength and provisions this expansion is evolving at, and simultaneously has discovered the resolution for this advancing supergravity element. His predictions tell the story of an expanding universe that's time clock seems to be in correlation with Hubble law, but also, and most importantly, it has made it possible for him to calculate conditions about the expansion of space that tell a different story than just universe expansion. It tells a story of what Kavetsky has named as the universe reverse vacuum space field drive. It is a new theory that illustrates the expansion conditions of the universe, and enabled him to create new equations not only for space expansion but also for a sound and special formula for a repulsive reverse vacuum space medium. This new theory allows for faster than light space travel under standard conditions formed by an expanding universe, the ability to travel distances across the cosmos in direct line with the ability to make sense of the material universe's effects of expansion with acceleration. For the last of its kind, Rodney Kavetsky has deciphered a new theory on space travel that takes us beyond the sci-fi stories of science fiction and time travel and brings us back to the reality in the standard model. His is a new theory blooming before your eyes that will take mankind on a final journey through the stars to places never before thought realized before. With these equations, we will be able to advance space travel to places so far away in lesser time equated by any other physics theory that by only the gain of propulsion engineering and that capacity to do such for advancement that will not put us on hold by using the universe's own vacuum instrumental with force in addition with normal acceleration methods, so we can travel to any newly mapped Goldilocks planetary system within our grasps and extend new planetary inhabitances for the Earth's human race. The universes. Have you ever looked up at the night sky and wondered if we are truly alone in the universe? For millennia, that question has sparked our imagination. But what if the answer isn't light years away, but right here in our own solar system? What if there are hidden oceans, teeming with the potential for life, just waiting to be explored? Today we read diving deep into one of the most exciting frontiers in space exploration, the ocean worlds of our cosmic neighborhood. Forget dusty red planets for a moment, and picture this: vast, salty oceans, larger than all of Earth's oceans combined, hidden beneath thick shells of ice. These aren't science fiction. They're real moons orbiting giants like Jupiter and Saturn. Let's start with Europa, one of Jupiter's Galilean moons. On the surface, it's a cracked, frozen wasteland. But beneath that icy crust, scientists are almost certain there's a global liquid water ocean. What makes Europa so special? It's believed to have all three key ingredients for life as we know it: liquid water, a source of energy, and the right chemical building blocks. The energy comes from something called tidal heating. As Europa orbits the immense gravity of Jupiter, it's constantly being stretched and squeezed. This friction generates enough heat to keep its subsurface ocean from freezing solid. It might even power hydrothermal vents on Europa's seafloor, just like the ones on Earth that support entire ecosystems, completely independent of sunlight. Imagine what could be thriving in that dark alien sea. Then we journey further out to Saturn, where we find Enceladus. This tiny, bright moon is a true showstopper. The Cassini spacecraft flew through massive plumes of water vapor erupting from cracks in its southern polar region. It was like Enceladus was advertising its hidden ocean to the cosmos, and when Cassini sampled these plumes, it found water, salts, silica, sand, and complex organic molecules, the very stuff of life. The presence of silica is a huge clue, suggesting that, just like on Europa, there are hydrothermal vents on the seafloor of Enceladus, creating a warm, mineral-rich environment. For a moon so small and so far from the sun, it's astonishingly active and one of the most promising places to look for extraterrestrial life. But the list doesn't end there. There's Titan, Saturn's largest moon, a world that is bizarre and fascinatingly familiar. Titan has a thick atmosphere, weather, clouds, rivers, lakes, and seas. But there's a twist. On Titan's frigid surface, the liquid isn't water, it's methane and ethane. However, beneath this hydrocarbon landscape, models strongly suggest a deep, salty water ocean lies hidden. Could life exist in such a complex, layered world? Perhaps in the water below? Or maybe even a completely different form of life that thrives in liquid methane. Even distant Triton, Neptune's largest moon, and the dwarf planet Pluto show tantalizing signs of subsurface oceans. These discoveries have completely changed our understanding of where life could exist. Habitable zones aren't just about the right distance from a star anymore. They can be created by the gravitational dance between a moon and its giant planet, generating internal heat and keeping water liquid far from the sun's warmth. So, what's next? NASA and other space agencies are already planning future missions. The Europa Clipper mission is set to launch soon, designed to perform dozens of close flybys of Europa, mapping its ocean and scouting for potential landing sites for a future probe. Imagine a robot that could one day melt its way through the ice and swim in an alien ocean. The Dragonfly mission will send a rotorcraft drone to fly through the thick atmosphere of Titan, exploring its surface and sampling its organic chemistry. The search for life is one of the most profound endeavors we can undertake. These ocean worlds offer us a tantalizing possibility that the first contact with alien life might not be with a technologically advanced civilization, but with microbial life thriving in the dark depths of a hidden sea within our own solar system. The universe might be stranger and more wonderful than we've ever imagined. Next time you gaze at the stars, remember the hidden oceans out there and wonder what secrets they hold. Thanks for watching. If you found this cosmic journey as exciting as I did, be sure to hit that like button and subscribe for more deep dives into the mysteries of our universe. See you next time.